Breaking ground, Ukrainian forces set to implement laser technology in combat against 100-plus Shahd drones. On February 11, 2025, Ukrainian forces are making significant strides in the integration of laser technology to combat the threat posed by over 100 Iranian-made Shahd drones deployed by Russian forces. This report outlines the advancements and operational capabilities of laser weapon systems within the Ukrainian military framework. Overview of advancements. Colonel Vadym Sukharevskyi, the commander of Ukraine's Unmanned Systems Forces, has been at the forefront of these developments, stating that Ukraine has successfully integrated laser technology into its military operations. The first acknowledgement of this capability came in December 2024 when Sukharevskyi highlighted Ukraine's position among a select few nations equipped with operational laser weaponry. The laser system, dubbed Tryzub, is designed to effectively target aerial threats at altitudes exceeding 2 kilometers. Particularly aimed at neutralizing the Shahd drones. The timeline of these advancements has been closely tied to the onset of Russia's full-scale invasion of Ukraine in February 2022. Since then, Ukraine's defense sector has experienced rapid growth with the establishment of the Unmanned Systems Forces less than a year ago. This unit integrates both combat and research teams that operate across various domains, air, land, and sea, reflecting a robust response to the evolving aerial threats posed by Russian military capabilities. Operational capabilities. The Tryzub laser system has been highlighted as a critical component in Ukraine's strategy against drone incursions. Early reports suggest that the system has already been utilized in combat scenarios with success in engaging aerial targets. Although specific operational successes are yet to be comprehensively verified. Colonel Sukharevskyi has indicated that the laser technology has already been effective against certain Russian targets. In addition to laser technology, Ukraine's military has also embarked on deploying long-range drones capable of traveling up to 2,000 kilometers while carrying substantial payloads. This shift toward advanced military technologies signifies a broader commitment to enhancing both defensive and offensive capabilities against the backdrop of ongoing conflict. Research and development initiatives. The integration of laser systems into the Ukrainian military's arsenal is part of a larger research and development initiative aimed at creating effective countermeasures against aerial threats. The emphasis on R&D reflects a proactive approach to military innovation. With Colonel Sukharevskyi noting that various areas of research are being explored to enhance the effectiveness of these technologies. Reports indicate that the Ukrainian military's efforts are not only focused on immediate combat scenarios but also on long-term strategic capabilities. The rapid development of the Unmanned Systems Forces and the introduction of laser technology represent a significant advancement in Ukraine's defensive posture. Significance and future implications. The significance of the Tryzub laser system cannot be understated. It represents a leap forward in Ukraine's defense capabilities, particularly against the backdrop of the persistent drone threats from Russia. As the conflict continues, the effectiveness of laser technologies could play a crucial role in shaping the outcomes of air engagements. The commitment to integrating cutting-edge technologies into military operations reflects Ukraine's determination to adapt and respond to evolving threats. The successful deployment of the Tryzub system could not only bolster Ukraine's immediate defensive capabilities but also set a precedent for future military innovations. Conclusion. In summary, Ukrainian forces are breaking new ground in the implementation of laser technology as a countermeasure to the ongoing threat posed by Shahd drones. The advancements made by the Unmanned Systems Forces, coupled with a robust research and development framework, showcase Ukraine's commitment to enhancing its military capabilities in the face of adversity. As the conflict evolves, such technological innovations may prove pivotal in determining the course of engagements in the airspace above Ukraine. The integration of laser systems marks a significant chapter in Ukraine's defense strategy, reflecting both the urgency of the current situation and the potential for future military advancements. With the ongoing development of these technologies, Ukraine is positioning itself as a formidable player in modern warfare, ready to confront and neutralize aerial threats effectively. The content presents a significant advancement in military technology, particularly focusing on Ukraine's implementation of laser weaponry to combat the threat from Iranian-made Shahd drones used by Russian forces. A few counterintuitive points emerge from this information. 1. Perception of laser weapons. Traditionally, laser weapons have been viewed as experimental or futuristic, often associated with science fiction rather than practical military applications. However, Ukraine's successful integration of laser technology into active combat operations challenges this perception, illustrating that such technologies can be developed and deployed effectively in real-world scenarios even in a relatively short time frame. 2. Speed of development. The timeline suggests that Ukraine has rapidly advanced its defense capabilities in response to the conflict with Russia. The establishment of the Unmanned Systems Forces in less than a year and their swift adaptation of advanced technologies contradicts the notion that military innovation takes extensive time and resources. This shows that in times of urgent need, nations can pivot and innovate quickly, potentially reshaping the landscape of modern warfare. 3. Operational success versus verification. While Colonel Vadym Sukharevskyi claims that the laser system Tryzub is operational and capable of engaging high-altitude targets, there is a caveat regarding the verification of these claims. This highlights a counterintuitive aspect of military technology where operational success can be claimed without independent verification, raising questions about the reliability of such technologies in actual combat scenarios. 4. Integration of aerial capabilities. The mention of long-range drones capable of carrying substantial payloads suggests a multidimensional approach to modern warfare. One might assume that ground forces would lead the charge in technological advancements, but the content indicates that aerial capabilities are equally prioritized, showcasing an understanding of modern combat's complexities where air superiority plays a crucial role. 5. R&D investment in conflict. The narrative communicates that Ukraine's defense industry has gained momentum since the full-scale invasion, which might imply that warfare can serve as a catalyst for technological innovation. This counterintuitive notion suggests that conflict might accelerate advancements in military technology faster than peacetime initiatives, contradicting the belief that peace is a prerequisite for significant technological progress. 6. Geopolitical dynamics. The deployment of laser technology, particularly in response to Iranian drones, reveals the intricate geopolitical dynamics at play. One might assume that such advanced technologies would be reserved for major powers, yet Ukraine, a nation facing aggression, actively develops and employs these systems. This challenges the idea that only larger militaries can effectively utilize cutting-edge technologies. In summary, the deployment of laser weapons by Ukrainian forces not only signifies a shift in military tactics but also challenges conventional wisdom regarding the development and application of advanced military technologies in modern warfare. The report detailing Ukraine's advancements in laser technology to combat Iranian-made Shahd drones deployed by Russian forces contains several elements that may be overlooked but are significant for understanding the broader implications of this technology in modern warfare. 1. Operational status and verification of claims. One of the often overlooked aspects is the lack of independent verification of operational successes of the Tryzub laser system. While Colonel Vadym Sukharevskyi has made assertions about the system's capabilities, the reports indicate that these claims remain somewhat unverified. This is significant because it raises questions about the reliability of the technology in real combat scenarios. Military technologies, especially cutting-edge systems like lasers, often face challenges in actual deployment that may not be evident in lab conditions or initial tests. Without independent assessments or documented operational successes, the perceived effectiveness of the laser system may be inflated, potentially impacting strategic planning and resource allocation. 2. Historical context of development. The timeline of Ukraine's rapid military advancements since February 2022 highlights an important narrative of resilience and innovation in the face of aggression. The establishment of the Unmanned Systems Forces within a year underscores a notable shift towards modernization in Ukraine's military capabilities. This transformation is significant as it illustrates how conflict can catalyze rapid technological development and restructuring within a military organization. Understanding this context is crucial for recognizing how nations under threat may prioritize and accelerate military innovation. Setting precedents for future conflicts. 3. Integration of diverse military domains. Another critical point is the integration of laser technology within the broader operational framework of Ukraine's military forces, which now spans air, land, and sea. The report indicates that the Unmanned Systems Forces are not just focused on one aspect of warfare but are innovating across multiple domains. This multi-domain approach is significant because it reflects a contemporary military strategy that recognizes the interconnectedness of different operational theaters. It also suggests that advanced technologies like lasers are not standalone solutions but are part of a comprehensive strategy to counter threats from various platforms, including drones and aircraft. 4. Shift in military doctrine. The emphasis on laser systems as a countermeasure to drones represents a significant shift in military doctrine. Traditionally, air defense systems have relied on kinetic interceptors such as missiles to neutralize aerial threats. The adoption of laser technology indicates a strategic pivot towards directed energy weapons, which offer unique advantages such as lower operational costs per engagement and the ability to engage multiple targets rapidly. This shift is significant as it may herald a broader trend in military strategy where nations invest in non-kinetic capabilities that can provide effective, sustainable responses to the evolving landscape of aerial threats. 5. Geopolitical implications. The development of laser technology in Ukraine has broader geopolitical implications. It suggests that Ukraine is not only defending its territory but is also positioning itself as a technologically advanced military power in Europe. The ability to deploy advanced systems like Tryzub could shift the balance of power in the region, encouraging other nations to reconsider their defense strategies and alliances. Moreover, this advancement could potentially attract international support and collaboration as countries seek to partner with Ukraine on advanced military technologies. 6. Long-range drone capabilities. The report also mentions the deployment of long-range drones capable of traveling up to 2,000 kilometers. The significance of this capability cannot be overstated. It represents a strategic enhancement in Ukraine's ability to project power and conduct operations far beyond its borders. This capability allows for preemptive strikes and deep reconnaissance missions, potentially altering the strategic calculus for both Ukraine and its adversaries. The development of such drones signifies a shift towards a more offensive posture in the conflict, which may have repercussions for regional stability. 7. Innovation in military technology. Lastly, the focus on laser technology reflects a broader trend in military innovation driven by necessity. The rapid development and implementation of such systems in Ukraine may inspire other nations to accelerate their own R&D initiatives in similar technologies. This could lead to a technological arms race in directed energy weapons, fundamentally changing the nature of air defense and aerial warfare in the coming years. The significance lies in how this could redefine engagement rules and tactics in military confrontations as nations adopt new methods to contend with evolving threats. In summary, the report on Ukraine's integration of laser technology into its military operations highlights several critical points that merit closer examination. The operational verification of claims, historical context, multi-domain integration, doctrinal shifts, geopolitical implications, advancements in long-range capabilities, and the broader trend of military innovation collectively shape a narrative of transformation in modern warfare. Understanding these elements is vital for grasping the future landscape of military technology and strategy, particularly in the context of ongoing global conflicts. 1. Advancement of laser technology in military operations. Ukrainian forces under the leadership of Colonel Vadym Sukharevskyi have made significant strides in integrating laser technology into their military strategy. The Tryzub laser system represents a pivotal development capable of engaging aerial threats, notably the Iranian-made Shahd drones at altitudes exceeding 2 kilometers. This advancement marks Ukraine as one of a select few nations with operational laser weaponry, highlighting the technological leap in their defense capabilities in response to ongoing aerial threats from Russia. 2. Rapid development of the Unmanned Systems Forces. The establishment and quick advancement of Ukraine's Unmanned Systems Forces, formed less than a year ago, signify a strategic pivot toward utilizing advanced technologies across multiple domains, air, land, and sea. This rapid development is part of a broader research and development initiative which reflects a proactive stance in adapting military tactics to counter the evolving threats posed by Russian military assets. The integration of combat and research units within this force underscores Ukraine's commitment to modernizing its military infrastructure in the face of ongoing conflict. 3. Long-range drone capabilities. Alongside laser technologies, Ukraine has successfully deployed long-range drones capable of traveling up to 2,000 kilometers with substantial payload capacities. This capability not only enhances Ukraine's defensive posture but also allows for offensive operations that can reach deep into enemy territory. The development of these drones signifies a strategic shift toward leveraging advanced military technologies, thus enhancing Ukraine's overall combat effectiveness in the ongoing conflict. For verification and operational effectiveness, while the reports and statements from Ukrainian military officials about the operational status and effectiveness of laser technologies are promising, there remains a level of uncertainty regarding the verification of these claims. Different sources offer varying degrees of focus, with some emphasizing operational successes and others discussing the technical specifications and capabilities of the laser systems. The need for independent verification remains critical to assess the true impact and effectiveness of these technologies in real combat scenarios, which could ultimately shape the operational landscape in Ukraine's ongoing conflict with Russia. 1. The development of the laser weapon system. The U.S. Navy's laws. In 2014, the U.S. Navy deployed a laser weapon system known as the Laser Weapon System laws aboard the USS Ponce. This system was developed to counter small boat threats and aerial drones, similar to Ukraine's current situation with Shahd drones. LAWS was significant for its ability to disable enemy equipment using directed energy, functioning effectively in maritime operations. The successful deployment of LAWS marked a pivotal moment in military technology, showcasing the potential of lasers in modern warfare. 2. The Strategic Defense Initiative (SDI) and space-based laser systems. Initiated in the 1980s under President Ronald Reagan, the Strategic Defense Initiative aimed to develop advanced missile defense systems, including space-based laser systems. Although the initiative faced numerous technical challenges and criticisms, it represented an ambitious attempt to utilize cutting-edge technology for national defense. Mirroring Ukraine's current attempts to integrate laser technology into its military strategy against drone threats. The SDI's focus on research and development paved the way for future advancements in directed energy weapons. 3. Israel's Iron Dome and laser defense systems. Israel has been at the forefront of integrating advanced technologies to counter aerial threats, particularly in the form of its Iron Dome missile defense system, which became operational in 2011. More recently, Israel has been developing laser-based interception systems as part of its defense strategy against rockets and drones, similar to Ukraine's efforts against Shahd drones. Israel's successful implementation and ongoing research into laser technology reflect a broader trend in military innovation aimed at intercepting low-flying threats and enhancing air defense capabilities. Future outlook: Ukrainian forces and the implementation of laser technology in combat. As we look ahead, the integration of laser technology into Ukraine's military operations against threats such as the Iranian-made Shahd drones marks a significant shift in modern warfare dynamics. The advancements made by Ukrainian forces signal a broader trend towards high-tech solutions in combat scenarios, and several predictions can be drawn from current developments. 1. Enhanced counter-drone capabilities. The operationalization of the Tryzub laser system is likely to set a precedent for the future of aerial defense. As the Ukrainian military continues to refine this technology, we can anticipate improvements in precision targeting and engagement capabilities against various drone types. The ability to effectively neutralize drones at altitudes exceeding 2 kilometers suggests that Ukraine may also develop countermeasures capable of addressing larger, more sophisticated aerial threats in the future. This could lead to a significant decrease in the effectiveness of drone swarms, which have become a notable component of modern military strategy. 2. Accelerated military R&D and innovation. Ukraine's rapid development of laser technology reflects a broader trend towards accelerated research and development R&D in military tech driven by urgent operational needs. As the conflict continues, we can expect an increase in collaborative efforts between the military and the defense industry, leading to innovative solutions for emerging threats. This partnership will likely foster advancements in autonomous systems, artificial intelligence, and integrated defense networks, pushing the boundaries of what's possible on the battlefield. 3. Potential for exporting military technologies. Should the Tryzub system prove successful in combat, Ukraine could emerge as a key player in the global defense technology market. Other nations facing similar drone threats may seek to procure or collaborate on similar laser systems. This would not only bolster Ukraine's defense capabilities but also provide a new revenue stream for its defense industry, positioning Ukraine as a significant contributor to global military technology. 4. Shift in military doctrine. The successful implementation of laser technologies will likely prompt a re-evaluation of military doctrines both within Ukraine and among other nations. As laser systems demonstrate their effectiveness in neutralizing aerial threats, we may see a shift towards incorporating directed energy weapons as standard components of military arsenals. This could lead to new strategies focusing on high-tech warfare, emphasizing speed, precision, and the minimization of collateral damage. 5. Increased focus on cyber and electronic warfare. Alongside advancements in laser technology, there will likely be a corresponding focus on cyber and electronic warfare capabilities. As drones become more sophisticated, the need to disrupt their control systems or navigation through electronic means will become paramount. Ukraine's ongoing integration of advanced technology may lead to enhanced capabilities in jamming and spoofing, creating a multi-layered defense against aerial threats. 6. International collaborations and military alliances. The current conflict and the technological advancements emerging from it may foster closer military collaborations among nations facing similar threats. We might see an increase in joint exercises, shared R&D initiatives, and intelligence sharing agreements. Countries with advanced military technologies may also offer support or training to Ukraine, further enhancing its operational capabilities and solidifying alliances in the face of global security challenges. 7. Ethical and strategic considerations. As laser technology and similar advancements become more prevalent, ethical considerations surrounding their use will be paramount. Questions regarding the implications of directed energy weapons, potential collateral damages, and the nature of warfare will necessitate international dialogues on regulations and norms governing such technologies. The discourse surrounding the ethical use of high-tech military capabilities will likely influence future arms control agreements and military engagements. 8. Evolution of aerial warfare. The introduction of laser systems will not only redefine Ukraine's combat strategies but could also influence the broader landscape of aerial warfare. Nations may invest in countermeasures specifically designed to evade or withstand laser targeting, leading to an arms race in aerial technologies. This could include improved drone stealth technologies, advanced materials that can withstand directed energy attacks, and backup systems for UAV operations. Conclusion. The future of Ukrainian military operations, particularly in relation to laser technology, is poised for transformative changes. As the conflict evolves, The successful deployment of systems like Tryzub will likely serve as a catalyst for broader advancements in military strategy, technology, and international collaboration. With ongoing research and development, Ukraine has the potential to not only enhance its defense capabilities but also to influence global military trends in the years to come. The integration of these technologies could redefine the parameters of modern warfare, emphasizing the importance of innovation and adaptability in the face of emerging threats.